Hello guys, in this video we will be discussing about the bus bar. So first of all we will be discussing about the KCL, Kirchhoff's current law, and how it is linked with the bus bar. Then what is the bus bar and what are the different types of bus bar, its housing and the types of materials we are using and the ratings of the bus bar and protections used for the bus bar and then the bus bar schemes in the bus configurations. So first of all, what is the KCL? That is the Kirchhoff's current law. That as we know that the current sum of the current entering a node is equal to the sum of the current outgoing a node. Like sum of the which is the input incoming current here, I1, I2. So as per Kirchhoff's current law, what is sum of the incoming current is equal to sum of outgoing current. So I4, I3, I5 and I6, these are the outgoing current. So which states that the sum of a current entering a node is equal to sum of current going out of the node. So I1 plus I2 is equal to I3 plus I4 plus I6. So that is, so this is the bus bar is a practical example of a node. So bus bar is nothing but a node here. So bus bar is required to connect multiple feeders together. So this is a bus bar. It is used to connect the multiple feeders, different feeders together. The feeder stands for both the incomer feeders as well as the outgoing feeders also. So incomer feeder means these are the source of the powers, and outgoing feeders means these are the consumers of the powers or the load of the powers. So here we can see F1 and F2, these are the incoming feeders. This means that this is the source of the power, and F3, F4, F5 and F6, these are the load, means these are the consumers of the power. So for all this connection we need a bus bar. So why bus bar is needed, that you have understand. So what we have concluded that bus bar is nothing but a node of a KCL, Kirchhoff's current law. Now you will be discussing about the types of bus bar. There are different types of bus bar. You will see rectangular bar, the tubular type, aluminum conductor, steel reinforced, ACSR, all aluminum conductor. Aluminum conductor means it is a good conductor, and steel is used here to provide the mechanical strength for the bus bar. So these are different types of bus bar arrangements we use generally. Then the bus bar schemes that we are using, their housing is there. What are the different enclosure for it? So we are having indoor type, outdoor type, SF6 gas type. Indoor type means inside a metal clad enclosure which will have a suitable rated insulators. It is a switchgear panels for the voltage rating of 415 volts. This will be having for 415 volts, 3.3 kV, 6.6 kV, 11 kV, like that. Another is the outdoor type, means the switchgear for the voltage of 33 kV, means 66 kV, 132 kV, 220 kV. Another one is the SF6 gas that is used for the GIS systems. So these are the different types of housing. So what are the different types of housing we have understand? Indoor, outdoor and SF6 types. And now you will understand about the materials. What are the different materials used in the bus bar? So bus bars can be have two materials. One is a copper and aluminum. Both is a good conductor of electricity, but copper is a good mode, but it is very high cost. So generally we are using aluminum due to its lightweight and the less cost. But copper has having a higher 2 times current capacity in comparison to the aluminum. Now we will be discussing about the voltage. What are the ratings of the bus bars? When we purchase the bus bar, what are the different aspects to be taken? Like we want to purchase the bus bar for the voltage rating of 415 volt, 6.6 kV volt, 11 kV. So first of all, voltage rating should be known. Then this is the continuous current. How much current should be passing through the bus bar? Means what are the full load? Means what are the different loads being connected? How much current need to be continuously flowed? That rating should be there. Like for example, if you are taking for the 2000 amps, so continuous means bus bar should sustain this 2000 amps continuously. Third point is the short circuit current capacity rating. Like you will be seeing that bus bar is designed for 40 kilo amps per second, means for 40 kilo amps of current for 1 second it can sustain. Like for example, if this is the curve for this 40 kilo amps for this, means it can sustain within this.
but if it is going outside this, the bus bar may damage. So bus bar should be such that it can sustain the continuous current as well as it can sustain the short circuit current capacity. Like for example, if it is 40 kilo amps per second or 50 kilo amps per second, it should sustain. That is, bus bar should withstand thermal capability also. So I square RT, heat is what? H equal to I square RT, that need to be constant. So I is how much? 40 kilo amps into resistance is constant, T is 1 sec, time we don't know, 40 square into T, the T is equal to almost 1 second. So 40 kilo amps per, if it is goes above that, bus bar will damage. Now I will be discussing about the protections that are used in the bus bar. So there are three different protections that are generally used in the bus bar. For example, you take this one, this is the incoming feeders, these are the two outgoing feeders. So the bus bar protection is very much important and much essential for the stable operation of the power systems. So since the bus bar is a node of a KCL and connects all the sources in the load together for stable operation of power system protection, so we have a protection overcurrent and earth fault, that is IDMT protections. In this what we are having 51 and 51N, means IDMT overcurrent, IDMT earth fault. Second is a bus bar differential protection, bus bar differential protection, and another protection is that is the sensitive earth fault, you can say, or the bus bar panel enclosure. This is the bus bar panel enclosure protection. Yeah, earth fault protections. What is happening now? What we will use this? What is the incoming current should be equal to sum of outgoing current. So what is the outgoing current? You will measure from one CT, you will put here, one CT you will put here. You will bring this both the CT. You will plus this and minus with this. If it is 0, it should not trip. If it is not so, means there is something problem in the system. It will trip the incoming supplies or the outgoing supplies, like that. And the same is for the bus bar enclosure, panel enclosure is what. So what we are having, if there is a bus bar and there is a switch gear, so we have a earthing of the systems. So we are having a one CT here and we are measuring the current in that, and if any current flows through that, will lead to a tripping of that bus bar panel enclosure or the earth fault. So this is the different types of protections that are being used in the bus bars. That means IDMT overcurrent, IDMT earth fault, bus bar differential protection, panel enclosure protection. But you will not find the panel enclosure protection generally. We are generally having a bus overcurrent and IDMT earth fault as the standby protection for the system, and the one is the bus bar differential protections. These two will generally found. Now I will be discussing about the different bus bar configuration. So bus bar configuration means what are the different bus bar schemes. We will have a single bus bar with sectionalizer, one main, one transfer bus, double or two main bus bar, double bus bar with a bypass isolator, one main or one reserve come transfer bus, two main, one transfer scheme. Now I will be discussing about showing you a diagram. Double, for example, a double bus bar. So how does it looks? Means double bus bar, as its name says, means two bus bar will be there. In this bus bar, we are having connectivity of like this. We have one isolator which we can connect to this bus bar 1, take it as a bus bar 2, and this we can connect through this isolator to this, and a single breaker will be going to the outgoing source. So for example, I will like to tell you, like we are having three different sources. Take it one here, it is source is there, one source is here, and one source is here. So double bus bar schemes are very costly, generally used at 6.6 kV or 11 kV lines. So this is generally about the bus bar, and at last I would like to conclude about the bus bar. We have talked about the bus bar, how KCL is related to the bus bar, different types of bus bar, what are the housings of the bus bars, and the materials which is used for the bus bar, and the ratings of the bus bar, and what are the protection schemes of the bus bar,
and different bus bar schemes and the bus bar configurations. Thank you all. Please like and subscribe my channel.